Okay, everyone, let us analyze the situation here in which I have a block sitting on a horizontal surface, and this block here makes up my system. Now, this horizontal surface here is able to become an inclined plane. And notice why I say that. I say that because I'm able to increase this angle here, causing the surface to tilt more and more, or I can decrease the angle, causing the tilt to reduce, therefore returning back to its original horizontal position. Also, notice the coordinate system here. So this coordinate system here has a y-axis and an x-axis. Now, when the plane is sitting completely horizontally, notice how the x-axis points completely in the horizontal direction and the y-axis points completely in the vertical direction. But watch what happens to the coordinate system as I tilt the surface more and more. In other words, as I increase this angle. As I increase the angle, notice how the coordinate system gets tilted along with the plane. Now, if I'm able to tilt this surface a full 90 degrees, notice now how the x-axis points completely in the vertical direction and the y-axis now points completely in the horizontal direction. Okay, so knowing the appearance of your coordinate system, it turns out, will be important in class whenever we're analyzing this situation here mathematically. So for example here, whenever we need to solve for the magnitude of the gravitational force acting on this block here, it's going to be important to know how much of gravity acts in the y direction and how much of gravity acts in the x direction in order to solve for the acceleration of this block here the moment this block begins to slide down this incline. Okay, so now that we've analyzed this coordinate system here, let us begin by analyzing the various forces acting on this block here in some detail. So as I tilt this surface here, it turns out there are various forces acting on this block, and we're going to analyze these forces one by one in order to get some idea of what's happening with the entire system. So let's begin with the gravitational force vector. So guys, look at this gravitational force vector here. Notice where it's pointed. It turns out that the force of gravity will always be pointed directly downward. And that should make sense because the force of gravity pulls objects toward the center of the earth. So whether or not your plane is tilted or it's sitting completely flat, this force vector will always be pointed directly downward. So what that means is when this plane is completely flat, the force of gravity acts solely in the y direction. And as I tilt my surface, gravity acts in both the x and the y direction. And you can see that here because watch what happens as I move this coordinate system over here just to show you guys what I'm talking about here. Notice how this vector here is acting in both the y direction and the x direction at the same time. Okay. Now, if I take my surface and I tilt my surface a full 90 degrees, now in this particular case here, gravity acts solely in the x direction, because again, it's always pointed straight downward. So keep that in mind as we analyze these problems in some detail coming up in class. Let us turn now to the normal force. So I have my block here sitting on my surface, and as of now, there's two forces acting on it. There's gravity and then there's the normal force. And of course, if this system is not accelerating, these two forces should be equal. The normal force should balance gravity. But guys, notice what happens to the normal force as I tilt my surface, as I increase my angle more and more, from 10 degrees to 25 degrees to 40 degrees, and so on. Notice where the normal force vector is pointed. Notice now it's pointed at an angle, it's slanted. And that makes sense because remember what we said, the normal force is always perpendicular to the surface of contact. And so we have this blue surface here, and this blue surface is obviously pushing upward on the block. And as it pushes with a force that is perpendicular to the surface of contact here. So remember we talked about that in class some weeks ago. And so no matter how you tilt your surface, the normal force will always be pointed in the y direction. Okay? And also, there's something else I want you guys to notice here. Look at the length of this normal force vector. Notice what happens to the length of this vector as I tilt my surface more and more. Notice how the length becomes shorter and shorter and shorter. And that makes sense because the more and more I tilt the surface, the normal force should continually decrease. If I'm able to tilt my surface a full 90 degrees, I should have zero normal force. And that makes sense because at 90 degrees, the block completely slides off the surface of the incline. And that should be obvious why that's the case, because at that point, gravity takes over and the block slides off. So if the block slides off, it's no longer in contact with this surface here. So think logically here. Zero contact means zero normal force. So you're going to always have zero normal force at 90 degrees and maximum normal force at 0 degrees. Okay, so keep that in mind. So here, maximum normal force, and it slowly decreases until we get to 0 at the 90-degree angle. Okay, so the final thing I want to discuss here is the last force under consideration, and that is friction. So we've already talked about gravity. We've already talked about the normal force. Now let us consider the frictional force vector when I tilt this surface here. So in this case, I'm increasing my angle to 10 degrees. Now, when I increase my angle of tilt, I notice that this block doesn't necessarily slide down the ramp immediately. And the reason why is because there's a force of static friction resisting it. Okay. Now, if I tilt the ramp more and more, eventually at some point the block will slide down. It will begin to accelerate down the ramp. And at that point that it would accelerate down the ramp, at that precise point there, the x component of gravity will have to be stronger than the static frictional force resisting the object. Okay, so at that point, that's where we're going to have acceleration, and that's where the block is going to slide down the ramp along this x-axis here. Also, guys, what I want to say here, whenever you're working on your homework, and for these questions here, when it asks you to draw a simple free body diagram for the block sitting on inclined plane, this is specifically what I'm talking about here. I'm specifically talking about this situation here. So your free body diagram should look like this for 0 degrees when there's no tilt. So you should only see two forces, a normal force and gravity. This should be your free body diagram for 25 degrees. You should see three forces, gravity, the normal force, and friction. And then here should be your free body diagram for 90 degrees. Right at the precise moment that the block begins to slide downward, that is no longer in contact with the surface here, and it begins to fall straight down. So right at that point, you have it's no longer in contact with the surface, so you have 0 normal force. So the only force that I should see on your diagram when you draw it is gravity. Okay, so that's what I want to see whenever you are answering these questions here and you're drawing your free body diagram. And of course, these questions right here, we've already talked about that a few minutes ago, so you can go ahead and answer those. And lastly, there's one more thing I want to say here before I pause this video. This frictional force vector here that you see, this represents the maximum static friction acting on this object for this particular surface. This does not necessarily represent the magnitude of the frictional force at this precise moment when the surface is tilted. It represents the maximum static force of friction. And as you can see, the force of friction always points along the x-axis. So now that we're done analyzing the various forces acting on an object that is sitting on an inclined plane, I want to look at an actual inclined plane that I have here that I purchased from Harbor Scientific. Now, as you guys can see, so we have our object here sitting on our surface. And notice my surface, I'm able to tilt it some angle. So here the angle is at 25 degrees. And I can continue to increase this angle of tilt more and more until eventually I approach 90 degrees, where this object is hanging completely in the vertical direction. And by the way, the reason why this object is not falling down is because there's a hook here. But if that hook wasn't there, obviously gravity would take over and this object will continue to fall down. So I can either increase the angle or I can decrease the angle of tilt. Okay, so what I'm going to do, I'm going to pause the video and then I'm going to zoom in on the incline and I'm going to start that recording again. Okay, everyone, what I want to do now, I want to analyze an inclined plane in real time and see what's happening to the forces as we look at our system. So I have an inclined plane here, and notice on the surface of the inclined plane, I have a scale. And so this scale is able to read the object's weight. And remember, the object's weight is the normal force. So guys, watch what happens when I take a 500-gram mass and sit it on the scale. Currently is zeroed out. So I'm going to take the 500 mass and I'm going to sit it on the scale. Okay. And notice it's reading somewhere around 489 grams, which is close to 500 grams. And of course, if we multiply that by 9.8, that'll tell us the object's weight exactly. Okay. So this number here is telling us something about the object's weight, which is the normal force. Now, I want you guys to notice something carefully. I want you guys to notice what happens to this number here as I slowly increase the angle of tilt of the incline. So let's see what happens. Okay, so I'm going to take my incline here and I'm going to slowly increase the angle of tilt. Slowly. What do you guys notice? What's happening to that number? As you guys should see, that number is getting smaller and smaller and smaller. And that makes sense because remember what we said earlier, as you increase the angle of tilt, the normal force should decrease. And that's exactly what we see. We see the object's weight is decreasing. So it's somewhere around, as you can see, somewhere around 486. And I am, a little higher than 15 degrees. Looks like I'm closer to 20 degrees. Now, look what happens to that number as I decrease the angle of tilt. So as I decrease the angle of tilt, okay, notice that number goes back up again and it's somewhere around 500 grams. Okay, so we just saw what happens to the normal force as we vary our tilt in real time.